Hello, everybody. Welcome to this webinar, which focuses on the use case for passive optical LANs in airports. The webinar is being sponsored by Tellabs and features a panel of experts who were instrumental in the success of LaGuardia Airport's Terminal B construction project. The panelists for today are Al Lyons, Firmware Director of IT in Electronic Systems for HOK, Joel Fisher, Sales Engineering Director for Tellabs, Nicholas Vermeer, Solutions Architect with Convergence. My name is Patrick McLaughlin with Cabling Installation and Maintenance, and I will moderate this discussion. We're going to have an in-depth discussion about the LaGuardia Airport project with these pros in just a moment, but I just want to take a minute of your time for some housekeeping before we get underway. First, I want you to know that the end of this session can include your questions for these experts. Please submit your questions at any time during this session. We will collect them, and as time permits, we'll have Q&A with questions that came from you, our audience members. Please do submit questions throughout this session. Also, if you're tuning in today during our live broadcast on August 31 and you are a BICSI credential holder, then you can earn a continuing education credit toward credential renewal by attending this live broadcast today. A note to those who attend several of our web seminars, a BICSI continuing education credit is available only to live attendees. If you're viewing on demand, this seminar does not qualify for a credit, but if you are live today, it does qualify for one. I'll have information about an attendance certificate when we're about to wrap up. So as kind of a summary of the construction project that took place at LaGuardia Airport, I guess it's safe to say that the deployment of the passive optical LAN was a departure of sorts, and I guess that pun is intended, departure from the status quo. Today's conversation is going to take us through the planning stage, the building stage, and the daily operations of that LaGuardia project. So I'm excited to be part of this discussion and ready to get started. Welcome again to everybody. Welcome to our panelists. Thank you very much for joining us. I wondered if we could start by sort of talking about, I know this was an award-winning project, and at the risk of being a little off the cuff, you know, the members of the Academy and all of that, wondered if it would be appropriate to acknowledge members of the team, in addition to those who are here talking to us today, which groups, which organizations, and maybe, you know, maybe individuals even who contributed to the project success. And I wondered if I could start with, you know, with the panel who's familiar and ask if there's any acknowledgments that you'd like to make of other team members.
Yes, this is Al Lyons. The airport, LaGuardia, is operated and managed by the Port Authority of New York and New Jersey that manages all the airports in New York. For this project, it was built about 50 years ago, the original LaGuardia Airport, and it was sort of not falling apart, but I guess, yes, falling apart. It wasn't a very good condition. So the Port Authority decided to go out to the market for a design, build, operate proposal, and they had wisely selected LaGuardia Gateway Partners, which was a consortium of Vantage airports in Vancouver, and then several other members, but was led by Vantage. Then the LaGuardia Gateway Partners put together a team which comprised of Skanska Walsh, which is a joint venture, and they're the contractors that actually built everything. And then we had the design partnership, which was WSP and HOK. WSP designed in all the roadways and the central heating refrigeration plant, and HOK designed the terminal itself and did the master planning for the entire airport. Then there was a myriad of other sub-consultants on the design team as well as on the construction team, and the most important ones, in my opinion, were, of course, Convergence, designing the network, and Tellabs providing all the equipment that enabled us to make the project work.
Thank you, Al. Thanks very much for that perspective on the on the team involved, and appreciate you three members of that team being here to tell some of the stories today. Thank you. Be back to you in just a moment, Al, with a question, but wanted to start with Joel, if I could, talking about, starting with the planning stages, and wondered if you could start with some of the basics, some of the essentials. What is a passive optical LAN for those who are not familiar, and maybe some detail on its specific applicability to an airport environment, because I know that we will be reaching a number of professionals who work in and around airports with this broadcast. So a passive optical LAN in general terms and its applicability to an airport environment.
Sure. So passive optical LAN is really an alternative, if you would, to a copper-based network, what we're all used to putting in, a copper-based switch network. And it really is a switched network unto itself. It just operates a little bit differently. The things that passive optical LAN definitely brings into an airport environment, the first being reach. When we start looking at normal Ethernet connections, we're fairly short distances. And when we look at a terminal, we look at the distances involved in a terminal. How do I provide power to things everywhere without having to run conduits everywhere? Passive optical LAN gives you reaches in the 12 to 18 mile distance. So I can start reaching things in an airport without large quantities of infrastructure to support it. I can simply pull a fiber or a cable out there with power and be able to run things at a distance. So, right off the top, we have that number one. And when we also look at things like closets, if you look at the beauty of the architecture in LaGuardia, I mean, it's open, soaring spaces. Where do you put things, right? There is not spaces for closets. There is not spaces for extra pieces of equipment, right? So the ability of optical LAN to reach these distances, not require immediate rooms, have easy maintenance on it, be able to just run reliably and constantly. That's what we look for. And in an airport, these things really come to bear.
Thank you. Yeah, thanks, Joel. And Al, sort of picking up on what Joel just described, I'd use the term fiber to the edge, right? It sounds like that's what a passive optical LAN brings to an airport. In this particular case, LaGuardia Airport, and that bringing fiber to the network edge sounds like it pays benefits in this case and in many cases.
Yeah, one of the things that was unique about LaGuardia is that it had a whole lot of existing networks and systems that were built over the last 50 years. And we wanted to bring all those systems to operate over the single passive optical network. So we created an integrated test facility out in Bohemia, Long Island, where all the existing instances of the existing systems and all the new systems were put together to prove that they worked. And we invited the owner from LaGuardia Gateway Partners to come, from the Port Authority, and everybody got to see the systems in a trial basis when they were actually, the building was just getting built. And this bought a whole lot of time. So we knew the systems worked. They were already installed, tested, and commissioned before the building was built. And that took about probably 6-7 months off of the construction schedule, which is hugely important in terms of costs and just getting it done. Right.
Yeah. Being in the trade media business, I have been known to use a buzzword or two every now and then, and including convergence. But it sounds like in this case, a buzzword of mine really came to fruition for your team, for the airport itself, and for the users of the airport. That the systems really did converge and were able to converge over this optical infrastructure, it sounds like.
Yeah. We, from a design viewpoint, knew it worked from the beginning, but actually demonstrating and proving it to the airport, the airlines, and everybody else was really critical to actually have their confidence too when we deployed it in the building.
Right. Thank you. Nick, thanks for joining us, and I'd like to bring you into the conversation, and hopefully building on the conversation up to now. When I think, of an airport, a lot can happen. An airport, is almost a representative of a city, right? I can go shopping, I can get my shoes shined. I just also happen to be able to, catch a flight all the way across the country. But there really are, so many services and really different businesses within the airport itself. So wondered if you could sort of address that, from whether you want to call it from a real estate standpoint, Nick, or really what I'm trying to open up to you is, how does a passive optical LAN sort of serve or maybe even benefit that sort of dynamic space and experience that is an airport, in this case, LaGuardia Airport?
Yeah, you definitely hit the nail on the head. It's the airport is a real estate environment. So they are renting space to various entities, including service providers, to the airlines themselves, and then to the tenant amenities, stores and gift shops, etc. And one of the things that PON does give you is that, especially from a vendor like Tellabs, is that it has a history of being a telecommunications delivery platform for service providers that are providing independent services in various methodologies, in subdivisions, in cities, in municipality, networks. And so it does handle, I need to give service to these different entities, and they're all independent groups, and they need to do different things that never the two shall cross. But then also I need to do a wide area, or what would be, if I was a Verizon, a wide area network for an entity. They've got 3 or 4 stores within an environment. They want to talk between each other. It does that perfectly well as well. And it has the monitoring built in for those types of services. It's very, service provider first of a platform, or at least that's its heritage. They have definitely moved it into an enterprise service entity as well, or an enterprise equipment or network environment. But it does have a lot of those capabilities, the ability to give different entities different speed allowances. Even though that the circuit may be able to do a gigabit, you may only be selling that entity a certain amount of speed as part of their amenity service from, the Vantage running the airport. And then it really allows us to easily deploy within that environment as well. We can have devices or fiber sitting in many locations in use, and then have ports that are currently open or available, or even fiber strands that are open and available, and then turn those up as needed as the environment changes. I mean, we had to do. We have people move in and out, but then we also had the ribbon cutting. The governor came in, and we suddenly had to get internet and TV egress connections so that the governor could come in and do a ribbon cutting. Right. And you have 12 hours to figure out how you're going to do that. Well, in this environment, you just go, oh, well, they just get internet at that port, and they get the guest internet service, and it gets mapped to it. It's not managing, 75 switches and figuring out which switch that is the VLAN extended to it, is everything, connected all the way through. You just apply the service profile to it, you're done. So,
excellent. Thank you. Thank you. I understand that, another part of the planning consideration was aesthetics. We were talking about, the space of an airport. I am familiar with airports only as a passenger. So I'll admit that when I'm in an airport, I'll look up to see where I can find a Wi-Fi access point. And if I see a visible cable, I'll take note. But that's just that's just what I do. My familiarity with airports really is as a passenger, like many others. I don't always think about, but sometimes admire, the space that is in an airport and the aesthetics of it. long intro from me, but the point I'm trying to get to is that aesthetics must have been a consideration while this network was being planned. So I wondered if I could go back to Al for a moment and ask if you could detail some of those considerations, Al. What were the aesthetic considerations that you had to consider? And then how did, of course, this discussion being about passive optical LAN, how did passive optical LAN either fit or really enable some of the aesthetics that were part of the plan?
Okay, the image is an image of the old LaGuardia Airport from about 2000, prior to 2014. And this is about the time when Vice President Biden came and visited LaGuardia and mentioned that it was a third world airport. And I think that sort of got under people's skin, and they really wanted to make this, we all wanted to make it happen. So what we were able to do was build the new airport on top of the existing one. The original bridging document, or the RPW, Required Program of Works, from the Port Authority envisioned phased demolition of the existing terminals and reconstruction of new terminals. We took a different approach, which was an alternative design approach, and actually built the new terminal on top of the old existing terminal. And this enabled us to only shut down one gate throughout the whole construction project. All we lost was one gate in the terminal, which was huge in terms of maintaining capacity and service throughout the whole project. So actually, during construction, the building kept getting nicer and nicer for people and passengers. So what we have is we put a, I think the next slide, if we could go to the next slide.
Sure.
What this is, we put MDF, main distribution frame rooms, in the CHIRP, the central heating refrigeration plant. The ugly green on the bottom and the ugly green on the top was Concourse B. So these were built in the first phase of construction, and they were connected together. The OLTs for the terminal are in the MDF rooms. And then we took a splitter, and this was a telecommunication splitter for the existing terminal, and this was the Temporary Terminal Operations Center, or TTOC. So we were able to start operating the whole building, the old facilities and the new facilities, from an integrated operations center, which then gave the people from LaGuardia Gateway Partnership an ability to get trained and familiar with all the new systems. So as they transitioned to the final location for the Terminal Operations Center in the head house, everybody was used to working, so they all worked together seamlessly. And the real advantage of the passive optical network is all we ran was a multiple strand single mode fiber from one end of the building to the other, and we're able to then pick up all the existing control rooms and everything and all the existing things and bring them into a single system that worked. So this is the final thing where here's the Terminal Operations Control Center, and this part of the building was still in existence, so we brought the fiber back over one of the bridges to connect here. But we're able to operate the whole building as a single airport terminal.
Right. Nick, that sounds easy, right?
It was hell. Yeah, the interconnect. So what we initially did is they pulled the cable across, and so the new airport is a common use system. So that's the airport term for converged network, sort of, for them, or it's all of the systems are running together. And the old airport was proprietary network, so everybody had their own networks. And so what we ended up having to do was interconnect one at a time with each of the existing networks and either move them depending on if the vendors were the same. But sometimes you had a losing vendor and a winning vendor, where the losing vendor was leaving the system when the construction was completed, and the winning vendor was going in, and we had to do integrations there. So we spent a lot of time doing interface control documents, interviews with the different entities, a lot of testing of systems, a lot of So the nice thing about the system is we could put devices into test networks that were isolated from everything else. The layer 3 environment, which is not on the telebs itself, but they were all VRF isolated for those who deal with the IP world. So each one has its own independent routing instance. And so we could bring them in, run them independently, prove that the integration worked, and then slowly connect them across. But it was many, many days of integration, but it was far easier to do it with this type of equipment than it would have been with a traditional LAN switch. You'd end up with, I mean, the first thing that you'd run into when you connect the two devices together would be spanning tree trying to fight each other. You'd have like an existing spanning tree network and whatever your new network was, and they'd start going at it, and one would try to take over the other. And with the PON, it's its own redundancy protocol. It's built intrinsically to be the service provider platform. It doesn't rely on spanning tree. It doesn't rely on the traditional switch environment for that access layer piece. And so it was very easy to, do different types of interconnects, stage things on the network, bring things up transitionally, and then actually cut stuff over, where at the time of the cutover, it was just a software switch. So you'd figure everything out ahead of time. And then when you actually had to do the flash cut element, you just, clicked a button, which is, was much better than many other flash cuts I've been involved in.
Excellent, thank you. Few seconds of my, Joe Sixpack observation, as of an airport going through as a traveler. Large open spaces, the ceiling's way up there. That's why I say I look for a Wi-Fi access point or something like that. But my understanding back to this conversation now is that as wide and cavernous as it might be, limited space really can be a concern and probably was a concern in this project. And wondered if I could ask both of you, starting with Al, was that the case? Were there situations in which having a limited amount of space was a challenge for you, and that a passive optical LAN was a sensible system to use as a result?
Yeah, actually, the whole of LaGuardia was originally built on an old amusement park ground, which is now below the floodplain. So whenever there's a flood, the ground floor can get flooded. And that meant we couldn't put any of our IDFs on the lower level. So they all had to be up in the expensive real estate where we're trying to keep the building. So we tried to make them as small as possible. And that had a huge impact by being able to use PON to reduce the number and the size of the closets. That's what makes it one of the things that makes the building so beautiful.
Great, thank you. And Nick, is that something you're sort of living day to day, right? Confined spaces and working within them?
Well, the folks out there on site every day certainly are. When we were doing the implementation, the first floor, one of the things was so one of the airlines, we delivered their service, their internal LAN, and we needed to put the splitter in their environment, and we were able to do that because it wasn't active. So there was this rule: we weren't able to put anything electric below like 6 feet off the ground, or 4.5 feet off the ground, or something like that, because of that flood rule. But the splitters there's no electricity on them. They're just a passive element. So we were able to put those in, and then they put the ONTs up on the desk level, and we were able to deliver the service down there and not have to worry about, well, where are we going to put a swing gate, and how are we going to get electric to it in this closet? Oh, the electricians have already taken all of the wall space that's above that point, because this is a closet that they've already started using. It was much easier to deal with than trying to put in a rack of traditional switches and to service that area.
Thank you. Thanks to you both. We're we're going to move on in a moment from the planning aspect to the building aspect. But before we do, Joel, I know you're still with us. Thank you very much for, for hanging in there in this discussion. And I just want to ask you before we move from plan to build, some of the discussions that we've had here, particulars about everything from cosmetic considerations to floodplains and whatever else of the like. I know no project is typical, and there are no cookie cutter projects, but these types of conversations that we're having here that played out in the construction project for LaGuardia Airport, are they typical, or are they sort of in line with some of the work that you do with Tell Labs in your engineering role to plan a project to put a passive optical network in an enterprise type environment, whether it be an airport or something similar enterprise wise?
Oh yeah, very much so. All projects are different unto themselves. Architects have different visions and beautiful visions of the way things should look, and space, as much as we would like all the space we could get from a networking perspective, big closets and racks and all the things that go with it, you have to consider this in literally every project, and even something that we really haven't touched on quite yet. Security. Security is a huge concern, and all of these same components are from the smallest projects all the way up through LaGuardia. They come to play in almost every design that we do.
Excellent, thank you. Moving to build, I know we got a little bit into build when we had that sort of final sketch, but I guess officially rather than unofficially moving to build. Al, I'd like to ask you first, off the top, when it comes to build, talk about capital expenses, capital savings. Early in this conversation, you talked about savings that were achieved by doing some testing off-site, ahead of time, and wondered if there are other examples of capital savings that were achieved. And again, because we're talking about a passive optical LAN here, can you sort of identify specific capital savings that were achieved versus a traditional setup because the passive optical LAN was used?
Well, I think also with the initial integration test facility, that's become a pre-production center where all the new versions of software and stuff are tested and proved before they're deployed in production. And that mitigates any surprises, which results in huge savings. The other savings is power. We don't use as much power with a passive optical network as you do with a conventional network. That requires less cooling because you have less power there. And so that represents huge savings in terms of energy and actually construction, because you don't need to build as large or as many MDFs and IDFs around the building. So you're saving not just on our equipment costs, but for actual the hard construction, the air conditioning, and the ongoing energy that it takes to run the building. So you'll see that's the first platinum, airport. That's LEED platinum, and that's partially because of all the different things we did to reduce energy consumption.
Thank you, Al. Nick, I imagine you have some commentary there, but I'll say that a little birdie told me that part of the construction of it, part of the construction of the network included pre-connected fiber, which was a capital savings. I wonder if that's the proverbial tip of the iceberg, or if that's something that that was substantial in terms of capital savings. It sounds like you're muted, Nick. Not sure if that's intentional or if you're able
Sorry
to.
Sorry about that.
Thank you.
I did mute because I coughed and then I forgot to unmute myself. So it certainly was part of it. Corning was a partner on this project, and we used their hybrid fiber to run the horizontals out to where the actual ONT devices were. And rather than have field installed ends at the ONT side, we had Corning install them at the factory, and then we would pull them back to the IDF and splice on the connectors there. So we already had pre-tested ends that weren't on the pull side. They were on the side that was on the far end, and that let us cut a significant amount of the labor. One of the major issues with fiber is that the labor to install the ends is higher than for a copper network, but the actual fiber itself is cheaper in most cases. So we had 16-2 hybrid cable, so it had 2 fiber strands and 2 16-gauge conductors, and we were able to have Corning pre-cut them to our various lengths, and then we would pull them in the ceiling and then put them into spliced cassettes at the IDF side. So it was definitely a labor savings there, which then translates to a cost savings.
Thank you. And yeah, Al, you mentioned, you mentioned the power savings, which certainly translates not just to capital, but to operational, expense savings as well. Al, wondered if you wouldn't mind sharing your sort of view of life cycle. Talking about savings, and I'm talking specifically about the use of fiber as deep into the network as it goes, as opposed to being a copper heavy network. Is that something that came under significant consideration when the decision was made to go with the passive optical LAN?
Well, the real advantage is if you look at the conventional category type copper cabling, they last 10 or 15 years, and then they come up with category 8 or category 7 or something, and you wind up having to replace it. The advantage of going with single mode fiber has almost unlimited bandwidth. So you're never going to have to replace it. So instead of lasting 10, 15 years, it's going to last 50, 60 years. So it's a huge savings on a life cycle cost and disruption. And I think that's probably that and this first cost of space that you're saving, but it's going to save a huge amount of money in the whole life cycle. And in terms of the environment, we talk about global warming and LaGuardia slowly sinking into the ocean. We can do our bit to stop that from happening by being responsible in terms of what our design is and reducing the consumption of energy and resultant greenhouse gases and stuff.
Right. Thank you. And Joel, if I could bring you back in for a moment, it makes me realize that space savings is something that can be quantified. So wondered if you wouldn't mind spending a minute or two talking about that in general, or maybe specifically as it relates to LaGuardia and perhaps other airports, or more generally with other with other industry types, where in other verticals, the use of a passive optical LAN can achieve quantifiable space savings that can then be space that can then be turned to some other business use.
Oh yeah, most definitely. Right off the top, the amount of space in your closets decreases because you're not running switches there anymore. You don't have large stacks of equipment. We all have these images, that we've thought of in the past, where the door of the communications closet is propped open and there's a fan blowing in there because we've got HVAC problems. Well, that's actually not going away in a lot of places. The more equipment we put in and the more things we put on the network and the new video screens and the new visualization tools that we use, all of that equipment takes space. And so in multiple industries and other airports, many other airports that we talk to, they have an issue with where do I put stuff, right? Plus, they're running a business. So they're trying to realize revenue from their floor space and being able to give back closets or not require intermediate room, or in a stadium environment, thinking about I can reach everywhere in a stadium from a single closet if I want to, versus having to pour all of the concrete for all of that. It really changes the dynamic of how you space plan, right? And you know, we do this stuff not only in the airport environment. Of course, we do this manufacturing, warehousing, schools, and in each of these instances, it's giving back that space. You know, we very much talk about I don't need ladder racking. I don't need rooms full of racks. I end up in single racks in comm closets versus 10 racks. It's a very different way of looking at your network. And even to that point, some of what we do, and it's not as much in the airport because LaGuardia's got these beautiful high ceilings and everything that's there. But when I'm in traditional office spaces, the PON system installs in the ceiling, or it installs in a small box on the wall, right? And things emanate from there, and I can completely eliminate the need for locations to put stuff. So it very much is a much cleaner install when it comes right down to it.
Thank you. Thanks very much. Going back to something that was brought up a bit earlier, Al, in our when we were talking about planning, or designing, you mentioned, if I'm not mistaken, if I've been paying close enough attention, I believe that you mentioned, I think it was just one gate that was closed for business during the construction project. And please either confirm that I'm right about that, or correct me and let me know where I've gone wrong in that idea. There is a question there, but I believe that's the case, and that the point I guess I try to make is that it remained as close to 100% operational throughout the construction project. Is that right?
Yes, only one gate was taken out of service at a time. Sometimes the gate moved around a bit as the construction went on, but it was basically one gate. We had to actually build some new temporary gates, but we kept the same gate capacity of the airport throughout the whole construction project, which was, really key to maintaining operation of the airport.
Thank you. Thanks very much. And Nick, if I could follow on with you on that, I'm told it would be worthwhile to ask you about the construction environment and the cleanliness, or maybe lack thereof. I mean, this was a true construction site, so wondered if you could talk about relating this to the subject of the day. We're talking about a fiber optic build, and how fiber as the medium of choice was suited to the environment in which it was installed.
Well, there's a couple of things. One is that a single fiber drop was able to provide multiple connections. So at the end of the fiber, there's an access device, the ONT, that has at minimum 4 available ports on it. So we could go into environments that were relatively dirty, had dirty power in them, or unstable power, and put the fiber in place with potentially slack because maybe we weren't able to put stuff exactly where it needed to go immediately. Put an ONT there, get some devices online, get BMS devices up, get cameras online, so that it's a construction environment. You've got a lot of people moving around. You don't want stuff to walk off the work site. At a certain point, the physical security folks wanted to get cameras up and running so that they could watch the construction environment. So we could do that, and then not worry about, the welder next to them welding and hitting all the Cat 6 or lighting it up. We just had type 2 type DC circuits going out there. We could shut those off if we knew that there was a bunch of work going on that was potentially hazardous. But nothing's going to come down the fiber and burn out the expensive electronics. The worst case that we might have is a power supply getting cooked. But even that, those devices are more robust because they're bigger power supplies in the IDFs. So we were able to handle the relatively harsh environments there, as well as we could have an outside plant fiber pulled to a construction trailer, and put a device there. Skanska Walsh's construction trailers got service from a lateral from a manhole. So we had a stack of ONTs in a construction trailer because they needed internet service.
Right.
So it was very flexible. It could handle the environment, and you didn't worry about things coming back and literally when you had the iron workers out there on the steel with a stick welder, I wouldn't want my switches connected to a bunch of cable that's going right by them. But we had fiber that was active during that time, and it didn't get zapped, and even if it had zapped the power supplies, it would have been a relatively minor event versus blowing a bunch of expensive switches.
Right. Thank you. Before we, I have one additional question before we move from build to operate. It refers to one of the slides that we had up earlier, and I will may have been this slide anyway. It looks like there were some single pathways between aggregation sites, and the question asks, was some type of optical fiber ring? Thank you. This is the slide we're referring to. Some type of optical fiber ring or diversity, I guess, used in these cases. Specifically, question, was Type B protection deployed here at the LaGuardia site at this project?
The foundation for the project was a thing called the RPW, Required Program of Works, that was put together for the Port Authority. And it did not require any redundancy until the final stage of construction. But what we did, instead of doing it that way, is we built the two MDFs first. And that enabled us to provide pond protection between the two MDFs. So we had one incident during construction, I'm sure you remember, Nick, when the water pipe broke in the strip, and it took out one of the OLTs. But the end users and the airlines didn't notice it because the pond protection worked and everything flipped over to the ONT, to the OLT that was in Concourse B. So I think, the thing is it did work, and in terms of diversity routing cables, there was no requirement for it. So we do have diverse routing at the final end of the project because we thought it was a good thing to do, but it wasn't a requirement.
Yeah. So during the construction project, there were periods of time where equipment was not fully protected, but by the time it was ever in service, it would have routes to both MDFs and have Type B protection. So there were periods before acceptance of gates or things to go into service, before ORAT periods where things would be single fed. But then by the time anything was ever going into service, it was fully redundant. And there was actually an enhanced redundancy that we put in where we did a striping of the splitters. So when we first built it, we had the splitters in various rooms sort of connected to the service cards linearly. So the 4 splitters in a IDF or 8 might be on the same cards. So if we had a card failure on the primary side, then all of those splitters would have to fail over. Or if there was some issue with the protection, there might be multiple splitters that could go out of service during that cutover. And that was identified as a potential risk. And so we actually went through and did a diversification of that. And we now split it up so that every splitter in a IDF is being serviced by a different line card, basically going across. This is similar to what you do in a normal active network, where you would potentially at each jack run say you did a 4 copper out to a remote location, you'd run those 4 off of 4 separate IDF switches, so that if any one IDF switch was to go completely out, you wouldn't lose all of your runs to that location. but this is giving us protection across much larger areas, across a larger space, and it does still have protection switching over. This is just to protect the amount of devices that are switching in the event of line card failure or something like that.
Great, thank you. Thanks for taking us back there and allowing that question. Operate is the final of the three. We've planned, we've built, and now we've operated. Listen to me, including myself in the conversation. Like when I say of my favorite football team, we won, as if I did any more than sit on the couch and watch, which is kind of my role. Thank you. Nick, want to stay with you for a moment and just ask if you can tell us a little bit about, in the operational stage, the ease of management, ease of maintenance that really comes through the DNA, if you can call it that, of employing a passive optical network, passive optical LAN in this airport.
So one of the benefits of the passive optical LAN, as far as the operation is concerned, is that the PON views itself as though it's sort of a chassis switch, with each of the remotes being a line card of that chassis switch. There's also a GUI-based configuration manager, but probably the core piece of it is that when you're configuring your devices, you're not logging into 100 different devices. They're all really just end devices of these core elements. And so the configuration is much more centralized. Even if you're not using the GUI and you're just doing like the initial stand-up of the system through a command line or craft interfaces, you're seeing much more of the overall structure of the system in one place. And this is something that the entire industry is going towards, but they're sort of going back towards that, trying to make a overall system run in a campus, whereas this is just natively that. This is natively a system-based platform where the remotes are part of the system, not additional devices that you then have to get to agree to communicate in the system. I think all of us who've dealt with switch networks have had the let's find the misbehaving switch hunt, where it's which device in this IDF with 20 switches is the thing that's doing the wrong thing. So it's much easier to just manage it from that. And then with the GUI and the templating that's built into this, it's even additionally made easier because it's based on a service provider environment. So you create service templates, and then you apply the service templates to ports. It's not purely a network centric ideology. It's not adding VLANs and adding QoS parameters independently on switches. You sort of create, this is a service for the BMS network in this building. It has this VLAN, it has these QoS parameters, it has all of these things. And then I'm just applying those to these ports. And if I need to switch it to a different port because you get a call on the day of install and they've flipped around which ports they're plugged into, and it's 40 feet in the ceiling and they don't have a lift to go and change it at the time, you can just go in and in the drop down switch the two around, and it takes you 2 minutes. I think we've all been on command lines and had to figure out which port I'm on and make sure I don't mistype something, and am I cutting and pasting this into the right window, and you don't have any of that.
Excellent, thank you. Thank you, Nick. I want to bring up the issue of security, because in the coverage that I've done of passive optical LANs, I have come to understand and write a little bit about the inherent security of the system. I wondered if I could maybe start with Joel and sort of if you could, Joel, sort of take us through the inherent security characteristics and attributes of the passive optical LAN in general, and then maybe here at LaGuardia if there are specific examples or whatever. And then Nick, I think I'd ask you to back up what Joel says with your particular experience.
Yeah, so security is built in. It's traditionally we used to think of security as I've got the network and then the devices on the ends of it have to provide the security for themselves, right? In a passive optical network, the links themselves are secured and encrypted. Access to the system is completely secured. There's no open holes, if you will. The devices that you place around, that actually have the Ethernet ports, you can place them in an open public space because there's no console ports on them. There is no way to kind of break into the system out at the edge of the network. And then when we look at it from the core equipment is all in the MDF in a very tightly, highly controlled space. So we literally in the idea of putting these devices out at the edge, fiber connected Ethernet ports out at the edge, we leave them in open spaces all the time, right? We're not worried about people plugging something in because the system controls all of that. There is not, there's no kind of open holes to the system, right? And it's designed for that. Then it goes into very high security systems, and the airport is a very high security system, right? It may look peaceful and serene sometimes when you're going through it, but there is a lot of stuff going on in the back end. Even the diversity that Nick talked about earlier. You should be able to lose an entire chassis within the system and then lose a card in one of the backup chassis, and your cameras are still covering all of your locations within the terminal. So even when you apply security beyond just what the system itself does, the design of it allows you to enhance your overall physical security as well when you're doing this.
Yeah.
Thank you.
Yeah, I would add, so in the traditional environment, there's a protocol called MACsec, which allows for secure encrypted links between the switches. But if you've ever tried to implement that without buying $100,000 of additional software from the vendor to do orchestration, you know that it isn't a lot of fun. The passive optical network uses a encrypted protocol between the remotes and the chassis that just works out of the box. I mean, you don't have to go in and roll your own certificates and enable MACsec on the links and do all of that. You just literally in your startup, you just enable the security. Well, the security is enabled by default if you have that pack on your Panorama install, and they just all come up encrypted. So it is possible, as someone who used to do cybersecurity, it is possible to tap passively optical links. It's harder to do on the really high speed stuff now, but on single mode fiber, I've done it with the little passive taps where you can get the gigabit service out without actually breaking the connection. And if you don't have it encrypted, then someone could read that. Now, it's a fairly advanced attack, but at an airport, you can't disregard the potential of an advanced persistent threat. And that's the professionally paranoid speak for, a intelligence agency / terrorist group. There are smart people out there who want to do damage to things. And so you do have to have a little bit higher bar at an airport on your network. Right. There's, physical security cameras and such on the network that are potential, targets. There's lots of other stuff on the network that we don't want people getting access to. There's the common use, the gate computers and check-in counters and things like that. Right. You don't want people walking up to those and plugging in their laptop and doing something nefarious. So there are a number of things that we have to consider there, and it is much easier in this environment to just be at a much higher basic level of security. It's just on by default and just works by default in those cases.
Thank you, Nick. I'll let you take a half a sip of water, but I want to follow up with you on another question. Following up on security, I want to ask about reliability. Earlier in this conversation, I believe I heard you, I heard you mentioning spanning tree protocol and how LaGuardia adopted, an alternative to that for the better. Wondered if now that we're talking about the the operation stage. If you could detail that a bit for us, and and talk about reliability of the passive optical LAN as opposed to what a user is in store for if they have another option, if they've employed another option.
Sure. So actually, Tel Labs did some development with LGP and C1 on the reliability and the failover scenario. So one of the things we talked about was the fact that we do striping so that the various splitters are not all on one line card in an IDF. Well, if you were to stripe in a traditional network, you'd have multiple switches in the IDF, and then you'd run different cables to different units. And you're usually doing that because you always assume that you can lose one physical piece of equipment. And that last switch is always something you could lose, regardless of how redundant that switch might be. When we're talking about it in the PON, we're talking about a double failure having to occur for us to get to a point where that striping has actually mattered. Not only do we have to have lost the line card, but we have to have the protection switch not work. So we're actually doing tests where we say, okay, the protection units are offline because that IDF has or that MDF for some reason is out of service, and we lost this line card. Now what's the impact to the airport? So we're actually doing double failure scenarios to do these tests out there, whereas in a traditional network, that would be a single failure event. You'd have a single switch down that's had we usually assume like a software bug has taken that switch offline. So regardless of how hardware redundant it is, it's down. And so, yeah, that's one of the areas we went to, because they have to, the airport operator has to be able to give the TSA details on events that occur. And if they can't, they have to stop operations. So if there's always double coverage on cameras, there's always, or multiple coverage. So all these things that are there, much of which we're not ever allowed to talk about, but there's a lot of things that go on to the operation of the airport that that go back and forth between the security agencies and the operators. And if something was to go wrong in that, then for security, they would shut the airport down. They might roll the baggage off. There's all these different things that they can do, but we don't ever want that to happen. We don't want these things to stop the airport. So we have to put in a lot of controls so that even in the event of failures, we assume that devices are offline. We simulate devices being offline. We actually pull power on things. We have to make sure that we still have enough coverage to meet all the security minimums, all the operational minimums. Gates don't shut down, flights don't get delayed, all of that.
Thank you. And Joel, wondered if you could amplify, that conversation, talking about really the sort of diversification as it relates to reliability, and of course the passive optical LAN's role.
Sure. Yeah. The stuff that Nick talks about, diversification, it extends across multiple systems in the airport. We're not just talking about the security. We're talking about baggage handling. We're talking about cameras, the PA system. And the other thing to kind of keep in mind when we're talking about this is we're doing this on an airport schedule, which it's kind of hard for some people to imagine that, your maintenance window may be set at 1 a.m, but if the last flight is late, you don't start until after the last flight has landed, and you're done. I forget the hour time, Nick, but before the first flights of the morning. So your windows may only be 2 hours in the middle of the night, and that's it. And being able to do maintenance and reliability, to be able to have this diversification, to switch to the secondary system and know it's going to be there when you're in those types of tight time frames, and maybe your window cuts short for some reason that you didn't even expect. It would just happen multiple times, when we're doing work out there.
Thank you very much. I know that we're close to an hour. I appreciate our audience hanging in there. I have one more question I'd like to ask Nick, and then maybe just 1 or 2 questions from the audience. So we're going to be a little more than 60 minutes in duration here, but I trust everybody has found the time to be worthwhile. Thanks to those of you who have joined us. If you have to go, I thank you for the hour that you've spent with us. If you're staying with us, thank you for that. And this will be another handful of minutes of worthwhile information and knowledge. So a final question from me, Nick, really human error. My understanding is that there are several ways in which the use of a passive optical LAN reduces or maybe eliminates the human error factor in operation. I wondered if you could just sort of give us maybe a bullet point overview of how that is the case.
Yeah, it has to do probably in this case primarily with the way Tellabs has built the management interface, but the use of templating allows us to build out the service profiles for a particular type of connection. At a gate, we might have the common use system, we might have the FIDS display or GIDS display, the phone and paging, and all of those are on different ports. And we have to then replicate that over and over and over again. And rather than doing that manually or in a text editor or something like that, or having to buy an additional cost system that's not part of the deployment, it's part of, the PON deployment is the management platform that allows us to then push that configuration and cross-check it on the protection side to build all of those ports out or change them on the application. So you're not going into each port and manually changing some of the low-level details of the networking protocol. You're applying that configuration around to it. So a big one is, like our spanning tree settings. The PON supports an edge spanning tree so that it can present spanning tree to remote devices. We don't really want people plugging switches into the network, so we were able to just apply across the entire board an equivalent to BPDU guard, where the ports will alarm if they see something trying to talk spanning tree to them by default, and then just allow it where we need it by applying a particular, okay, this is for this particular service, these folks use something that needs to talk spanning tree, we can just apply that. Rather than having to remember it or something, having somebody in a year from now remember how that was configured for that particular case is just part of that configurations template.
Thank you. Thanks for that. And thanks to everybody on our panel for this conversation. We're going to get into some audience Q&A, but again, realize that we're past the hour. If you're not able to spend any more time with us, I thank you for the time that you did spend. A little bit of housekeeping before we get into Q&A. I'll be quick, I promise. If you're a BIXI credential holder, you can use your attendance at this live event only, August 31st, for a continuing education credit. The way that it's going to work is this. Once we disengage and the seminar is complete, we will send an email to the address that you provided when you signed up for this event. That email is going to have a link to an attendance certificate. So BIXI recognizes all of that. We are accredited for this live event only and appreciate you spending some time with us. Our panelists are here. Want to let you know that there are some additional resources here. Please visit these websites for more information on passive optical LANs on this project in particular. So sorry to jumble all that up to you before we get into Q&A, and want to spend just a couple of minutes on this. Al, thank you very much for hanging with us while we talked operations and left you out of the conversation. But the first question is for you. Particular interest in your remote test rig that you brought up early in the conversation, and the question of all questions: how in the world did you persuade the multitude of users and not just suppliers to test on your remote rig? Did airlines cooperate? Could you give us a little more detail on how that went? A very intriguing part of the story, and wonder how much detail you can give us on it.
Yeah, it was a challenge because a lot of the airlines and stuff didn't really want to, but it's a common use terminal, so they're already operating over the network. And so some of the airlines did elect to get services provided by Converge One, and other airlines decided to put in their own little switches within their own parts of the airport. And it was pretty much the airlines decided how they wanted to configure it within their own space. But outside of their own proprietary lease space, they're all on the common use shared network. And most people, all the tenants are using the common use network. I mean, using the passive optical network. The only ones are some of the larger airlines have systems in place, and they wanted to keep their IT departments busy, so they kept separate networks. But everybody else is on the shared network.
Thank you. I think we've got time for one more question looking at the clock. So I'll ask, on the design, how were cameras supported? Was there an ONT for each camera, or did one ONT serve multiple cameras?
So the cameras are supplied by ONTs that are in the area. So there is a requirement for we use the 4-port ONTs, and the remote power by code can only be 100 watts, which gives us 60 watts of usable PoE on those ONTs. So we were able to do 2 cameras if the cameras were 30 watts. In some cases, we actually did 3 cameras because they had some 15-watt PoE cameras. But the ONTs do supply PoE out from them, and they receive just Type 2 cable or low voltage to them to supply their input power. So it's up in the ceiling. There would be ONTs sort of strategically placed so that they could connect to 2 cameras, or maybe a camera and a Wi-Fi, or if there were some camera clusters, there might be 3 cameras if there were the smaller camera types in there.
Thank you very much, Nick. And I think I will be able to end there, because there was one other question I was going to ask, but you answered it within the answer that you just provided about powering the cameras. It sounds like they were PoE, right? So the cameras were PoE powered. So the power went from the ONT to the camera via a traditional category cable, right?
Well, so the hybrid fiber carried the power to the ONT, and then the ONT provided PoE out to the cameras.
There you go. All right. And you know what? I am going to keep everybody on for a moment longer, because there's a question about Wi-Fi that I overlooked, but think is important to the conversation. Can you explain how the wireless network architecture interfaced or not with the passive optical LAN infrastructure? So was that wireless network, that Wi-Fi network, sort of incorporated into, connected to the passive optical LAN? Sorry, and that is the final one.
So the it's a controller-based wireless network that Converge One actually didn't do the work on. We were offered it, but we felt we were busy enough dealing with the actual PON install. But we did work closely with the wireless LAN installer, and the wireless LAN, the Wi-Fi WAPs are on the PON, and then they go back to their controller across the PON, and then the controller, it's a Cisco wireless solution, and they deliver the client. There's an ICE, and folks who deal with the Cisco wireless are familiar. There's a wireless controller, there's an ICE server, and then the VLANs would come out. They would connect back to the traditional network core to get to offload all their VLANs, and then traffic would often go back out the PON to other nodes on the network. So there are systems for like building management, where they access the building management endpoints from their cell phone. They have their corporate LAN connection they log into, and then are able to access the BMS endpoints.
Thank you. Thanks, everybody, for all of that. Thanks to the members of our audience who hung in there while we did some overtime with questions. I really appreciate everybody's attendance today. My thanks go to Labs, of course, for sponsoring and making this presentation possible. Our panel, Al Lyons with HOK, Joel Fisher with Labs, and Nicholas Vermeer of Converge One. Thanks, of course, to every member of our audience who joined us. And as a final reminder, you're just about there. If you need a Bixby credit, we're going to sign off. Once it is complete and you've made it with us all the way to the end, you will receive an email with a link to an attendance certificate. So on behalf of Cabling Installation and Maintenance and Endeavor Business Media, I thank you very much for your attendance today. And we hope we see you back here soon in a forum like this before much longer. Thank you all very much and have a great day.
Thanks a lot.